Hello everyone, in this video I'm going to show you a method through which you can find out roots of polynomials fast. So most of you must have found yourself into solving these kind of equations in many physical sciences problems, such as finding out the eigenvalues of matrices. So what really happens is we are given quadratic equations and we kind of solve them, but we are not able to solve when the order of the equation is much higher than 2. Like if it is cubic equation, then it becomes really challenging to solve that. Roots of this equation. So a typical equation is the multiplication of its factors. So over here, as you can see, f lambda has factors lambda minus a, lambda minus b, lambda minus c, and so on. So finally you kind of end up with this kind of equation, but now you have to focus on this constant part. Now this constant part is the multiplication of all the roots, which are a, b, c, and so on. So over here in our equation we have to focus on 1. So 1 is 1 cross 1, or it can be written as 1 cross 1. If there was 2 over here, then we would have written it like 1 cross 2. So it is just the factorization of the last number. So now we take the negative possibilities as well. That means we'll be putting, or we'll be kind of trying to satisfy any number to this equation. So I have already seen that lambda equals minus 1 satisfies this equation. That means lambda plus 1 will be a factor. So let's just see how this method proceeds. So what you have to do is you have to take two equal signs and then you have to write the highest power polynomial over here. So I have written lambda cube over here. Then you have to reduce the power by 1 and then write it over here in the lower row. And now since lambda plus 1 is the factor of this equation, what we will do is we will multiply it by lambda plus 1. So finally you will get this lambda square lambda plus 1, and then we'll be solving this equation. So we'll kind of find out that we'll have lambda cube plus lambda squared. Now since we have 3 lambda square in our main equation as the coefficient of lambda square, then we'll have to add 2 over here. So we'll be adding 2 over here. So now we have 2 lambda square. Now what you will do is you will reduce the power again, or the order again, of this 2 lambda square. So we'll have 2 lambda over here, and then we'll multiply it again by lambda plus 1. Then we'll be solving this and writing on the top. So we'll get 2 lambda square plus 2 lambda. Now again what we'll see is that there we have 2 lambda, but in the main equation we have 3 lambda. So what we'll do is we'll add plus lambda over here, so that we can kind of get the sum equals to 2 lambda, 3 lambda. Now what you have to do is you have to reduce the power again by 1, and then we'll just have 1 over here, and then multiplied by lambda plus 1. So finally what you will get is we'll get lambda plus 1 over here. Now you have to compare this last digit over here to the last digit of the main equation. If these digits are same, that means we have done everything correctly. Otherwise there must be some problem. Now you can write this main equation as this one, and now you can solve this quadratic equation very easily using factorization technique or Shridharacharya formula. So you will end up with these factors. So lambda equals minus 1, minus 1, and minus 1. So thank you for watching. Please do like, comment, and subscribe.